In the previous video, we looked at a quantitative way of measuring the quality of our code, right? And this is known as software metrics. However, oftentimes several code characteristics are not captured by such quantitative metrics. Sometimes when we write our code and let's say we reread it again, some lines of code, some functions, some variables, they might not seem right. Although they get the job done and they implement the feature, some characteristics of our code are not very elegant. And you might feel that they can be written better, or we can modify the code so that it can be a little more elegant. Right? So these inelegant pieces of code is known as code smells. So what are code smells? Code smells are nothing but certain problematic characteristics in our code. And an excellent resource for a list of such code smells can be found in a book by Robert Martin known as Clean Code. And it has a list of 63 code smells. So going through all of them is beyond the scope of this course, but we will be looking at some of them in this video. So there are code smells related to comments, right? So one such example is redundant comments, right? We should use comments only to explain why we have implemented a certain feature, right? Such comments like incrementing I by 1 is obvious by reading the code. Hence, we should avoid redundant comments whenever possible. Another code smell is commented out code, right? Often at times you would, while you develop or others, when they develop or write code, oftentimes they feel it's not needed and they comment it out, right? So Robert Martin suggests and strongly believes that such commented out code should not be part of the code base. It is best to delete it. The reason being, if someone wants to use it later on, as we saw, using version control systems, we can always get the history of our code. And it's best to remove out these commented out code. Another category of code smells are related to functions, right? And the key important principle to remember is that functions doing more than one thing is bad. So that is a code smell. So whenever we write functions, they should be short and they should do only one thing. So functions that are too long, right? That indirectly implies that they are doing more than one thing. So it's best to keep your functions short. And functions that have too many arguments. So Robert Martin suggests that ideally functions should not have any arguments, or they should have 1, 2, or at most 3 arguments. And if a function has more than 3 arguments, it might mean that it is doing more than one thing, and it is best to divide that function into multiple functions. And functions having flag arguments are also problematic, right? So what are flag arguments? So based on the value of the flag, the function will do a particular set of operations. And in earlier weeks, we saw that this is control coupling, right? And this is not desirable. And the solution for this is to again split this function into multiple functions, where each function implements a particular value of the flag. And then there are dead functions, which are functions which are not called by any function in your code base, right? So it's best to remove such dead functions. Then there are general code smells. So there are several examples. We will look at some of them. But a key and important principle is the dry principle, or don't repeat yourself principle. So what does this mean? So oftentimes, even when we write code, in the first run, we will have these groups of lines of code, right, which are identical, interspersed throughout our program, right? So the best way to avoid this is to put these identical lines of code in simple methods and call those methods in your program. So this is another example of the dry principle being violated, right? So you can see that there are multiple conditions, sub-conditions in the main condition. A way to fix this is to create a list and check if that variable is present in that list. So we looked at the dry principle. Another code smell is incorrect behavior at the boundaries, right? So even many a times when we also code, we fail to check the boundary conditions. And as developers, it is very important that our code satisfies the requirements for all conditions, even at the boundaries. And another general and very intuitive goal or idea is to use explanatory variables throughout our code, right? So in the previous example, let's say we had a variable called m, and oftentimes it's not very easy to understand what m means. Hence, a better way to rename m is to write something like 30-day months, which is self-explanatory. So always use explanatory variables in your code. So now let's say we have these code smells, right? How do you change your code such that these code smells can be removed? And that can be done using the process known as refactoring. So refactoring is nothing but changing the code by improving its structure, right, without changing its behavior. So let's say you have written your code and it works and it is satisfying the requirements, you have checked the boundary conditions, but then you realize that there are certain things which can be improved. For example, you might be repeating yourselves in several places, right? Your functions might be long, they might be having too many arguments. So once you finish writing your code, an important step is to refactor your code, right? Improve the structure of your code, remove code smells without changing the behavior of your code. And there are several tools which can help you refactor your code effectively. And there are tools in Python like Pylint, Flake, Kate, Vultr, etc. And in this video, we will be looking at Pylint. Pylint is a static code analyzer. So Pylint goes through your source code and checks for errors in naming convention, or it examines other code smells in your code. So let's see how we can use Pylint. So this is the same program which we saw earlier, which calculates the first n primes, right? And to use Pylint, I have to first install it. So I type in pip install Pylint for this user, right? And since I already have it installed in my system, it gives me these messages. And now I can type Pylint and the file name, right? And when I run this, I get several messages, right? And notice that these are not related to the input or the output or the logic of the program, but there are different messages related to, let's say, the naming convention. Here you say it's saying that a function or the doc string is missing, right? The argument or the variable does not conform to snake case, right? Which is in Python, the naming convention is to write or give underscores after each word, right? So that is known as snake case. So some of the arguments and variables do not conform to this style, right? And so these are messages related to the convention, which is C, and W is a warning sign, right? So in this way, Pylint gives us or gives details about how we can improve the naming conventions and structure of our code. So for example, here if I give a variable C equal to, say, some number 1, right? Or let's say if it's a very large function and I type in something here, right? A equal to 5, something, B equal to 10, right? And what Pylint does is it tells us that these variables C, A, B are unused, right? Those are warnings which Pylint gives us. And it also tells us that these line numbers, right? 25, line number 25 onwards is unreachable, right? And in a way, VS Code also gives us these warnings because VS Code itself has some linters pre-installed, right? So in most IDEs, you will see that it has some linters or static code analyzers pre-installed in them, and that's why you can use these linters in your IDEs as well. So now if I remove, so using such linters, you can look at how you can improve the readability as well as remove code smells in your code. So Pylint and other tools can help you do that.